0 seconds. The Chicxulub asteroid was roughly 6 miles wide. It hit the Yucatan Peninsula 66 million years ago at around 43,000 miles per hour, about 20 kilometers per second. The impact released energy equivalent to billions of nuclear weapons detonating simultaneously. It ended the Cretaceous period. It killed roughly 3/4 of all species on Earth. It's hitting again. Same place, same speed. The moment it contacts the surface, the asteroid and everything beneath it, ocean rock crust, vaporizes instantly. There's no crater yet. There's a rapidly expanding sphere of superheated plasma where the Yucatan Peninsula used to be. The temperature at the impact point exceeds 50,000 degrees Fahrenheit, roughly 5 times hotter than the surface of the sun. Anyone within 1,000 miles dies in the first second. There's no mechanism of survival at that range. The energy release is simply beyond any frame of reference that involves people still being alive. 1 second later, the fireball expands outward at hypersonic speed. Mexico City, 800 miles from the impact site, is engulfed within seconds. A city of 22 million people ceases to exist before a single person there has time to react to anything. Havana, 600 miles away, goes the same way. Guatemala, Belize, Honduras. Entire countries inside the fireball radius are vaporized or incinerated in the first few seconds. The Gulf of Mexico is simultaneously being displaced. The asteroid hit shallow coastal waters, and the energy transfer to the ocean is catastrophic. A column of superheated steam and vaporized seawater punches into the atmosphere with enough force to push material past the stratosphere. The shockwave is already moving, a wall of compressed air radiating outward at supersonic speed, carrying heat and pressure far beyond what any structure on Earth was built to survive. 5 to 10 seconds later, the shockwave reaches Central America and begins moving through the Caribbean. In Miami, 1,100 miles from the impact, the shockwave arrives with enough pressure to collapse buildings and shatter every window simultaneously. The city doesn't burn yet. That comes later. For now, it's the overpressure wave that does the work, snapping steel frames and dropping concrete structures in seconds. The same wave is moving north, south, and east simultaneously. In Bogotá, the ground shakes violently from the seismic energy traveling through the crust. Not from the shockwave, because that hasn't arrived yet. The impact transmitted enough energy into the Earth's crust to register as a magnitude 11 or 12 earthquake globally. Every seismic sensor on the planet pegs simultaneously. In Los Angeles, buildings sway and crack. In Tokyo, the ground moves. In London, people feel a low, deep vibration through the floor and don't know what it is yet. The Chicxulub crater is still forming. The ground is still moving outward from the impact point, a ring of displaced rock hundreds of miles wide, still expanding. 30 seconds later. The seismic waves are circling the planet. They travel through the crust and mantle at several miles per second, reaching the opposite side of the Earth in roughly 20 minutes. But the surface waves, slower and more destructive to buildings, are already hitting everything in the Western Hemisphere. In Rio de Janeiro, a city built across unstable hillside terrain, the shaking triggers landslides across the city's slopes. Favelas collapse. The Christ the Redeemer statue sitting on a peak above the city loses its base and falls. Fault lines that were already under tension are being pushed past their limits. The Cascadia subduction zone off the Pacific Northwest, which geologists have warned about for decades, ruptures. Seattle and Portland begin shaking from their own earthquake on top of the global seismic pulse. The San Andreas Fault goes simultaneously. The sky above the impact site is no longer sky. It's a column of ejected material, rock, steam, vaporized crust, rising past the atmosphere and into space. 1 minute later, the ejecta is already coming back down. Material blasted upward at high velocity follows ballistic trajectories, up and then back down, globally. Molten rock fragments, superheated and still glowing, re-enter the atmosphere across the entire planet within minutes to hours of impact. The process starts within the first minute at close range and extends outward over the following hour as the slower, higher trajectory debris reaches more distant parts of the globe. From the ground, it looks like a meteor shower, except it covers the entire sky in every direction at once, and the objects are not burning up. They're landing. Each fragment hits with enough energy to start a fire. In the Amazon basin, already partly on fire from the shockwave, the sky fills with glowing trails, hundreds of thousands of individual impacts per hour across the continent. This is not survivable in the open, not anywhere in the Western Hemisphere. 5 minutes later, the re-entering ejecta is now heating the atmosphere itself. This is the mechanism that makes a Chicxulub-scale impact different from every other kind of disaster. The sheer volume of material re-entering the atmosphere simultaneously creates a thermal pulse, a global spike in air temperature caused by friction from millions of fragments burning through the upper atmosphere at once. For a period of roughly an hour, the air temperature at the surface in many regions spikes high enough to ignite organic material spontaneously. Forests don't need to be hit by a fragment. The air gets hot enough to set them on fire. In New York City, 1,700 miles from the impact, the thermal pulse arrives like opening an oven door. Rooftops ignite, cars parked on streets catch fire. In Paris, across the Atlantic, 5,000 miles away, the pulse is weaker, but still real. The Seine reflects an orange sky. Dry building materials on exposed rooftops begin smoldering. The fires that start here will burn for weeks with nothing to stop them. 15 minutes later, the tsunamis are arriving at the coastlines. The displacement of the Gulf of Mexico generated waves that dwarf anything in recorded history. The 2004 Indian Ocean tsunami, which killed 230,000 people, was generated by an underwater earthquake. This was an asteroid impact into shallow water, releasing billions of times more energy. The waves moving outward from the impact site are hundreds of feet high and carrying enough momentum to travel miles inland across flat coastal terrain. Miami is already structurally compromised from the shockwave. The water arrives and takes what's left. The entire Florida peninsula goes under. The highest point in Florida is 345 feet above sea level, and the waves exceed that across most of the coast. Inland, the water slows but doesn't stop, pushing through the flattened suburbs and highway corridors until the terrain finally rises enough to stop it. Lisbon takes a wave from the Atlantic side. The city is built on hills. The upper districts survive the initial surge. The lower waterfront districts do not. The wave travels up the Tagus River estuary, flooding the city center. Further north, the British Isles absorb a reduced but still devastating surge across their southern and western coasts. Tokyo gets its wave from the Pacific side. The city's seawall, rebuilt and reinforced after 2011, fail completely. The coastal districts go under within minutes. The water reaches Shinjuku. 1 hour later, the global firestorm is fully underway. Fires that started independently across every continent are merging. The Amazon is burning, Central Africa is burning. The boreal forests of Canada and Siberia, the largest forest systems on Earth, are burning. These aren't fires that move at the pace of a normal wildfire. The thermal pulse has already preheated vast areas of dry vegetation, and the wind patterns generated by the impact shockwave are feeding oxygen into every fire simultaneously. Cities that weren't immediately destroyed by the shockwave or the wave are on fire. There are no functioning fire services. There's no water pressure because the water infrastructure is gone. There's no air traffic because every airport is either burning, flooded, or sitting in total darkness under a sky that's no longer the right color. The atmosphere above the northern hemisphere is filling with smoke. The smoke from burning forests and cities mixes with the ash and debris from the impact itself. The sky, which was orange an hour ago, is turning black. Several hours later, the fires are consuming oxygen faster than the atmosphere can replenish it at ground level in the worst affected regions. In areas surrounded by burning forest on all sides, oxygen levels are dropping. The fires are also producing carbon monoxide in quantities that make open air dangerous to breathe without filtration. Anyone still alive in the interior of a burning continent and not sheltered is dying from the air rather than from heat. The smoke plume from North and Central America is already crossing the Atlantic at high altitude. European cities that haven't burned yet are watching the sky darken in real time. Not from ash, not yet, but from the smoke of a continent on fire thousands of miles upwind. The light is wrong. Midday looks like late evening. Animals are behaving as if night has arrived early. The global communication network is fragmenting. Undersea cables survive for now. But the ground stations, the power infrastructure, the data centers, most of them are offline. The internet still partially exists in places running on backup power, but the picture it carries of what has happened in the past few hours is incomplete and increasingly dark. One day later, sunlight is losing the fight against the atmosphere. The combination of impact ejecta, fire smoke, and sulfur compounds from the vaporized Yucatan limestone, which was rich in sulfates, is forming a global layer in the upper atmosphere thick enough to significantly reduce incoming solar radiation. The effect isn't uniform. Regions directly under the smoke and debris get near total darkness. Regions further away get a deep gray twilight where the sun is visible as a pale disk through the haze. In London, what should be a spring afternoon looks like a winter evening in a city with a heavy smog problem. In Beijing, the daylight is gone entirely. People there are breathing through improvised masks. The temperature, which was mild at the start of the day, has dropped by several degrees already. The drop is accelerating. The fires are still burning. They'll burn for weeks. 2 to 3 days later. The temperature drop is measurable everywhere now. The 1815 eruption of Mount Tambora caused the following year to be called the year without a summer. It dropped global temperatures by about 1 degree Celsius and caused crop failures across the northern hemisphere. The Chicxulub impact is injecting orders of magnitude more material into the atmosphere. The cooling isn't going to be 1 degree Celsius over a year. It's going to be severe, fast, and sustained. Crops in the ground across Europe and Asia are dying from cold snaps that weren't forecast. The temperature swings are too rapid for plants to adapt. A field of wheat that was healthy 2 days ago is frost-killed overnight. Farmers who survived the initial event have nothing left to harvest and nothing to plant into soil that is already cooling past viability. The food system was already disrupted by the infrastructure collapse. Now the agricultural base itself is failing. 1 week later, the impact winter has arrived. Photosynthesis requires light. Under the current atmospheric conditions, most of the planet's surface is receiving somewhere between 10 and 20% of normal solar radiation. That's not enough. Plants that weren't burned are dying from the cold and the dark simultaneously. 2 stresses at once. Neither one survivable on its own, both happening together. The oceans are still relatively warm. Water retains heat much longer than land, but the surface layers are cooling. Phytoplankton, which form the base of the ocean food web and produce roughly half of Earth's oxygen, are starting to die off in the upper layers where light penetration has dropped below survivable thresholds. Anywhere that isn't on fire is going quiet. Animals are moving toward warmer, lighter areas, but there aren't many. The migration corridors are blocked by fires, floods, collapsed infrastructure, and terrain that simply doesn't exist anymore. 2 weeks later, the food chain is breaking down from the bottom. Plants dead, insects collapsing, small animals following. The process moves up the chain methodically, not in a single dramatic event, but in a steady, irreversible sequence. Predators that survived everything else are finding nothing to eat. Scavengers are briefly doing well. There's no shortage of dead material, and then they're competing with each other for a resource that's finite and not being replenished. The humans still alive, in deep bunkers, in well-stocked underground facilities, in submarines, in the handful of surface locations that somehow avoided the worst, are doing survival math. How much food, how long it lasts, what happens after. A few governments are still technically functioning. Military chains of command are partly intact in some countries. Orders are being issued into a void. There's no infrastructure to carry them out and no civilian population left in most areas to receive them. 3 weeks later, the surface of the Earth across most of the northern hemisphere is unrecognizable. The burned regions are black and ash-covered, with temperatures well below freezing. Snow is falling in areas that were tropical 3 weeks ago. Not because of normal weather patterns, but because the atmospheric cooling has collapsed the temperature gradients that kept tropical regions warm. The Amazon basin, half of which was incinerated, is now cold and dark. The surviving half is dying from frost. The southern hemisphere is doing slightly better. It's further from the impact site, it absorbed a weaker thermal pulse. And the atmospheric mixing between hemispheres takes time. Australia, southern Africa, southern South America. These regions are cold, dark, and increasingly desperate, but they're not yet at zero. They have weeks, maybe months. The people there know it. They're working with it. 1 month later, the Chicxulub event 66 million years ago produced an impact winter that lasted years. The stratospheric debris took decades to fully clear. In that window, the non-avian dinosaurs were gone. 3/4 of all species on Earth were gone. The recovery? The slow process of evolution filling the emptied ecological niches took millions of years. A month into the second impact, the trajectory is the same. The fires are mostly burned out because there's very little left to burn. The atmosphere is stable in its new dimmer state. The temperature has dropped by several degrees globally and is still falling. The oceans are cooling, the darkness is holding. Some people are alive, the number is impossible to estimate. Communications are too fragmented, the areas of survival too scattered. Bunkers in Switzerland, Norway, New Zealand. Submarines still at depth. Remote mountain communities that manage to store enough food and filter enough air. A research station in Antarctica that has been effectively self-sufficient for months and is now simply continuing what it was already doing. They're alive for now. The question is whether the biosphere can recover quickly enough to support them long-term. And whether the answer to that question is different for humans than it was for the animals that survived the first Chicxulub impact. Those survivors, the small burrowing generalist species that could eat almost anything and needed almost nothing, took 66 million years to produce us. The asteroid doesn't care how long the next attempt takes.